Good day. This is Teacher Angelo, your teacher for Practical Research. Last week, you were given an overview of what quantitative research is. Today, let us continue on your journey of discovering and understanding research further. We are going to talk about something that is essential in understanding quantitative research. The most essential learning competency covered for this episode is differentiate the different kinds of variables and their uses. Before we begin, let us answer the following activity. Statements will be flashed on the screen and you will identify the independent and dependent variables for each of the statements. You may get a piece of paper and a pen for you to jot down your responses. Are you ready? Let's begin. First statement. A researcher would like to investigate the number of mosquitoes killed by a locally made spray. What is the independent variable and what is the dependent variable? Second statement. During summer, electricity consumption gets high because of higher temperature. What is the independent variable and what is the dependent variable? The third and last statement is JC would like to determine if increasing the number of hours of exercise would increase his running speed. What is the independent variable and what is the dependent variable? Alright, just hold on to your responses first and we will find out the correct answers before the episode ends. So first, let us begin by defining what a variable is. A variable is a measurable characteristic whose value changes. They may take on values that are numerical or non-numerical. In science, the things that are changing in an experiment are called variables. In research, variables simply refers to a person, place, thing, or phenomenon that you are trying to measure in some way. So how are variables classified? Variables can be classified into three, based on how they are going to be used in research. They may be classified according to value, the scale of measurement used, and the relationship they take in an experiment or procedure. Let us first get to know the first classification of variables, the variables classified according to their value. Earlier, it has been mentioned in the definition that variables can take on either a numerical or non-numerical value. Hence, variables can be classified as either quantitative or qualitative. Qualitative variables are those whose data are non-numeric and whose observations vary in kind but not in degree. Examples of qualitative variables are sex, religion, and civil status. As qualitative variables allow for classification of samples, qualitative variables can also be called categorical variables. Quantitative variables, on the other hand, are those whose data are counts or numerical measurements and whose observations vary in magnitude. Their values result from counting or measuring something. Examples of quantitative variables are age, income, number of children, height, and weight. Quantitative variables can be classified further into two: discrete and continuous. Discrete variables are countable in a finite amount of time. They are also in whole numbers. For example, you can count the activity sheets given to you by your teachers. Madami, no? Other examples of discrete variables are the number of students in a class, the number of houses in a village, or the number of cars in a car park. Continuous variables are those whose observations can assume any one of the countless number of values in a line interval or between the highest and lowest points of measurement. Continuous variables would literally take forever to count. In fact, you can get to forever and never finish counting. For example, take age. Can you count age? Why not? Well, because it would literally take forever. For example, you could be 18 years, 10 months, 2 days, 5 hours, 15 minutes, 4 seconds, 4 milliseconds, 8 nanoseconds, 99 picoseconds, and so on old. Well, at least, my forever. Diba? Other examples of continuous variables are length, weight, and time. Variables can also be classified according to the scale of measurement used. These variables include their nominals, ordinals, intervals, and ratios. Nominal variables are also known as categorical variables. Their data are non-numeric labels that do not reflect quantitative information. They allow for the classification of samples into two or more categories. However, there are no intrinsic ordering of categories for nominals. Examples of nominals or categorical variables are sex, which classifies samples into males or females; marital status, which may classify samples into single, married, widow or widower; and religion, such as Jewish, Christianism, Taoism, or Islam. Variables where there is a meaningful order or categories but there is no measurable distance between categories are called ordinals. Ordinals may be similar to nominals as they are also categorical or qualitative. The difference is that ordinals have a clear ordering of the categories. However, due to the nature of their values, arithmetic operations are impossible, but logical operations can be performed. Examples of ordinal variables are the ranking of results of a competition, the top hits of today, such as the Billboard Top 100, and social economic status. Interval variables are those whose data values are ranged in a real interval and can be as large as from negative infinity to positive infinity. It is a measurement variable used to define values measured along a scale with each point at an equal distance from one another. Examples would include temperature and intelligence quotient. The ratio is the highest level of measurement. It has all the properties of the interval and it also has a clear definition of zero. Both the differences and duration of two values are meaningful and there is always an absolute zero that is also meaningful. Examples of ratios would include weight, height, and pulse rate. In a laboratory or scientific experiment, variables are classified according to the relationship they have on other variables. These include the independent variable, the dependent variable, intervening variable, moderating variable, extraneous variable, and the confounding variable. The independent variable is the characteristic of an experiment that is manipulated or changed by researchers, and not by other variables in the experiment. It is the variable which causes for a change to happen in another variable. The treatments done in a laboratory experiment or procedure are usually the independent variables of the study. On the other hand, the dependent variable is the variable that is being measured or tested in an experiment. Its value depends on the influence of another variable, which is usually the independent variable. Take note that the independent and dependent variables have a cause and effect relationship. For example, in an experiment looking at the effects of studying on test scores, studying would be the independent variable. Researchers are trying to determine if changes to the independent variable result in significant changes to the dependent variable or the test results. An intervening variable is a hypothetical variable used to explain causal links between other variables. Intervening variables cannot be observed in an experiment. That's why they are hypothetical. For example, there is an association between being poor and having a shorter lifespan. Poverty is the independent variable, while lifespan is the dependent variable. What could be the intervening variable? Being poor may not necessarily lead to a short lifespan. The association of being poor with a shorter lifespan may not necessarily be attributable to poverty, but may rather be due to a consequence of poverty, which is the lack of access to healthcare. Therefore, the lack of access to healthcare is the intervening variable. The term moderating variable refers to a variable that can strengthen, diminish, negate, or otherwise alter the association between independent and dependent variables. Moderating variables can also change the direction of this relationship. For example, the hours spent exercising may influence the resting heart rate. People who exercise more tend to have a lower resting heart rate. However, this relationship may be influenced by age. Age may influence how long one spends time exercising, and age may also influence the resting heart rate of individuals. Children generally have a higher resting heart rate compared to the elderly. Extraneous variables are all variables which are not the independent variable. However, extraneous variables has the potential to affect the results of the experiment. Therefore, the researcher wants to make sure that it is the manipulation of the independent variable that has an effect on the dependent variable. Hence, all the other variables that could affect the dependent variable to change must be controlled. Moreover, if an extraneous variable is not controlled by the researcher and influences a change in the dependent variable, this will now be called a confounding variable. In the experiment on activity level and weight gain, the activity level is the independent variable. However, there are still other variables that may influence weight gain, such as age, food intake or nutrition, and genetics. The researcher needs to control these other variables to make sure that any change in the weight of the participants is due to his activity level. If these variables are not controlled and influence weight gain, these variables are called confounding variables. Alright, let's go back to our previous activity and check your answers. Have you got them right or have you changed some of your responses? Let's take a look. For the first statement, a researcher would like to investigate the number of mosquitoes killed by a locally made spray. What is the independent variable and what is the dependent variable? The independent variable is locally made spray. The dependent variable is number of mosquitoes killed. Let's look at the next statement. During summer, electricity consumption gets high because of higher temperature. What are the independent and dependent variables? Let's find out. The independent variable is temperature, and the dependent variable is electric consumption. For the last statement, JC would like to determine if increasing the number of hours of exercise will increase his running speed. Let's identify the independent and dependent variables. The independent variable is length of exercise, and the dependent variable is running speed. How well did you fare? If you got the items correctly, then you are a fast learner. However, if you did not, then you may practice some more. Take note that you will need this competency to successfully complete your understanding of research. For our next activity, you need to write in the comment section a research problem or a title and identify its independent and dependent variables. This will serve as your class participation for today's discussion. In summary, variables may be classified into three types based on how they will be used. They may be classified as qualitative or quantitative based on the value they possess, or they may be named nominals, ordinals, intervals, or ratios based on the scale of measurement used. In an experiment, variables may be independent and dependent. Controlled variables can be intervening, moderating, or extraneous. If uncontrolled, they become confounding. For your assessment, you may check on the link on the screen or scan the QR code to access the reading form. If you want to seek clarification and further information on the concepts provided, you may consult your respective practical research teachers, Sir Jojen Cordova, Sir Jet Orande, Ms. Rhoda Penefiel, Sir Romal Peralta, and yours truly through your respective subject GCs. This has been another episode of Practical Research 2. This is Sir Angelo, and we will see you next week for another fun pananaliksik.